One of the nice things about implicit differentiation is that all of our derivative rules, the product rule, the quotient rule, and the chain rule, still apply here. We can still use those if we need them here. So here in this problem, I've got the equation 2x cubed y minus x cubed plus 5 is equal to 0. Now, in this problem, we're going to have to use the product rule, and I think it's a little bit sneaky here. We have here 2x cubed, which we're thinking about as a function of x. It's 2x cubed, but then we also have that times y, which again, remember, we are thinking about y as a function of x, f of x, which means that we're going to have to use the chain rule there, but we're also going to have to use our product rule here. So in this problem, maybe off to the side, just because this is a new thing, how about I call this f and I call this g? So f is equal to, let's see, that would be, 2x cubed. F prime would be 6x squared. G is going to look like just y by itself. And g prime, the derivative of y, is going to be 1 times y prime, or we can just write that as y prime. So keep an eye out for those product rules. Anytime you have any power of x multiplied by any power of y, when we take the derivative in our first step here, we're going to have to use our product rule. So our first step, I've kind of jumped ahead a little bit, but our first step, as usual with implicit differentiation, is to take the derivative of both sides of our equation. If I'm thinking ahead here, I've labeled f and g. I'm using my product rule, which says f prime times g plus f times g prime. We'll write it out here, and then now I'll go ahead and plug these in. So f prime is 6x squared times g. Here we said g was just equal to y, plus f, so that's going to be 2x cubed, times g prime, and in this case we can simplify g prime to just be y prime. So that first term, we're using our product rule. We'll see this happen where if we use our product rule, that one term kind of splits up into two just because of the nature of the product rule. But then at this point, we're done with that. We still need to then just take the derivative of the rest of our problem then. So the derivative of minus x cubed, that would be negative 3x squared. No powers of y there that we need to worry about. Derivative of 5 is a constant, so it's 0. Derivative of 0 is also 0. So now we have 6x squared y plus 2x cubed y prime minus 3x squared is equal to 0. And now at this point, again, we just want to get y prime by itself. So just like I said last time, we want everything that has a y prime, we want that on one side of the equation, and then everything else that does not have a y prime, in this case that's the 6x squared y and the negative 3x squared, we're going to move those over to the other side of the equation. So in this case, we're going to do a little bit of addition and subtraction here. So here I'll have 2x cubed times y prime is equal to 3x squared minus 6x squared y. So there's my first step. My second step then, since I only have this one term on the left-hand side of my equation, I don't need to do any factoring then. I should just be able to go ahead and divide by 2x cubed. So here we'll end up with y prime is equal to 3x squared minus 6x squared y divided by 2x cubed. Now in a problem like this here, I look at my numerator, and in particular, I'm seeing a power of x in every single term here. I actually can do a little bit of simplifying here. So I'm going to factor this out a little bit. In my numerator, I see a common factor of 3x squared. That would leave me with 1 minus y in my numerator divided by 2x to the third power. And now we can go ahead and cancel out a power of x squared from our numerator and our denominator, which means that we are left with 3 times the quantity 1 minus y all over 2x. So this is our y prime, and this is an example where our derivative is both in terms of y and x. We have both of them. Now in the next page when we get there, we're going to start to talk about how we can use the derivative, and the derivative, hopefully not a surprise, still tells us the same piece of information. It still tells us the slope of the tangent line. So if I wanted to find the slope of the tangent line using my derivative in this case, I would need an ordered pair. I would need both an x value and a y value here. So if I picked a point on my curve, just to show a really quick example here, let's say that I chose the point -1, 3 here. I would need to take the x value -1, plug that in for x, the y value 3, plug that in for y, and then just solve for y prime. So that process would look like y prime equals 3 times 1 minus y, here my y value is also 3, all over 2 times x, that's 2 times -1. So in my numerator I should have 3 times -2 all over -2. We can either simplify, I would just cancel the -2's now, and then that means that y prime is equal to 3. So when we evaluate our derivative, when we try to find the slope of a tangent line, we are going to need both an x value and a y value in many, not all cases, but in many, many cases.